Hello, everyone. Welcome to a panel discussion about the Permafrost Pathways project. My name is Barbara Moran. I'm an environmental reporter at WBUR, which is Boston's NPR affiliate, and I will be moderating the panel today. Permafrost is frozen ground that, as it thaws, is causing land to collapse, leading to an environmental justice crisis for Arctic residents whose homes and villages are at risk. Thawing permafrost can also release greenhouse gases into the atmosphere, worsening climate change. Today, we're here with 5 experts to discuss the science behind permafrost thaw, strategies for dealing with it, and policies that could help address the crisis. To start, I just want to introduce our panelists. You guys can just wave when I say your name. We have Dr. Sue Natali, the Arctic Program Director at the Woodwell Climate Research Center in Woods Hole, Massachusetts. Dr. Brendan Rogers, Associate Scientist at the Woodwell Climate Research Center, also in Woods Hole, or, because Sue's also in Woods Hole. Fran Ulmer, Senior Fellow at the Arctic Initiative at Harvard Kennedy School, who splits her time between Anchorage, Alaska and Cambridge, Mass. Dr. Robin Bronin, the Executive Director of the Alaska Institute for Justice in Anchorage, and Patricia Cochran, Executive Director of the Alaska Native Science Commission in Anchorage. Welcome to everybody. Thank you for coming. I'm really interested to hear what everybody has to say. So to begin, we're going to hand it over to Dr. Sue Natali for a brief overview of the Permafrost Project before we move into discussion. So handing it over to you.
All right, great. Thanks, Barbara. Let me just share my screen. So first, thank you everyone for being here. Thank you for the panelists as well for being here, but also being partners on this project. So I'm Sue Natali. I'm the Arctic Program Director. I'm one of the project leads for the Permafrost Pathways project, and I'm very excited and honored to be here to share our new initiative with you. So I'm going to give a very, very brief overview of the project, and then I'm going to hand the floor back to our expert panelists who are all project partners and project co-leads. And to start, as a project of the Woodwell Climate Research Center, I want to acknowledge that our campus is located on the traditional and sacred land of the Wampanoag people who still occupy this land and whose history, language, and traditional ways of life and culture continue to influence our vibrant community. Our research in the north, it occurs in northern areas across the circumpolar Arctic where Indigenous peoples have lived for time immemorial. And so, as Barbara mentioned, our work is motivated by the unprecedented warming that is occurring across the Arctic. The Arctic's warming 3 to 4 times faster than the global average. And this rapid warming is causing the once permanently frozen ground, known as permafrost, to thaw, which is transforming the region. It's creating hazardous conditions on the ground. As you can see, this is an example of a collapsing forest in Northeast Siberia, Russia. It's also threatening infrastructure and roads, homes, and the health, lives, and lifeways of Arctic residents. And permafrost thaw can also impact everyone on the planet because it stores a massive amount of ancient frozen carbon. There's about 1.5 trillion tons of carbon currently stored in permafrost, and when that carbon thaws, it can be released into the atmosphere as greenhouse gases, carbon dioxide and methane, leading to more warming and in turn more thaw, resulting in an amplifying climate feedback. And so these are the 2 of the main concerns about permafrost thaw. Carbon emissions from thawing permafrost are expected to be quite large. They will likely be on par with major greenhouse gas emitting nations, perhaps by the end of this century, as large as or even larger than emissions from the United States at its current rate. And a major problem here is that due to monitoring and modeling gaps, there's a lot of uncertainty and when and how much greenhouse gases will be released from thawing permafrost. As a result of this uncertainty, these emissions are pretty much omitted from international climate policy. And this is resulting in a severe miscalculation about how aggressively we must pursue emissions reductions and what actions we need to take to adapt to the hazardous conditions that are being created by climate change, included permafrost thaw. So to begin to address this major problem, we launched this ambitious new initiative called Permafrost Pathways. This initiative brings together a really amazing and growing coalition of scientists, Arctic residents, Indigenous knowledge holders, and Arctic policy experts and influencers to work together to tackle this problem with the urgency that we feel it deserves. So our project launched just 2 months ago, this past April, and it was launched with generous funding through the TED Audacious Project. So there are 4 key interacting components to this initiative, which include permafrost carbon monitoring, computer modeling, collaboration with Arctic communities to co-create an adaptation framework, and integration of this information into policy. So first, I'm just going to give a really brief summary of our scientific approach for monitoring and modeling the global impacts of permafrost thaw. So there's currently no integrated strategic approach for tracking and predicting carbon emissions from thawing permafrost across the entire Arctic. So as I mentioned, as a result of this gap, permafrost emissions aren't considered in most climate models, nor are they incorporated into global climate policy. So to address this gap, we're working with an international team of Arctic scientists to strategically identify and fill carbon monitoring gaps by upgrading and installing new equipment to monitor greenhouse gases across the entire Arctic, and including in remote areas where monitoring currently doesn't exist. And we're also using high resolution satellite imagery to track disturbances such as this abrupt thaw event shown in this picture and wildfire across the entire Arctic region, because these disturbances are really important both for the impacts on the land and the people on the ground, but also for global carbon cycling. And then we're using these field and remotely sensed data to build the first ever data assimilation model for Arctic carbon cycling. And this state-of-the-art modeling approach will allow us to accurately project permafrost emissions now and into the future. But we recognize that doing science just isn't enough, given both the magnitude and the urgency of the climate crisis. And so, as I noted, a major concern about permafrost emissions is that they're not accounted for in global carbon budgets. And the result of this is making it nearly impossible to keep global temperatures below 2 degrees Celsius or 1.5 degrees Celsius or any temperature threshold, because we're essentially aiming for the wrong target. So what we're doing is we're working closely with policy experts to make sure that our science outputs provide the information that policymakers need. This means running our models in a policy relevant time frame and using policy relevant scenarios. It also means delivering the current state of knowledge and the evolving knowledge to decision makers to ensure that permafrost thaw and the resulting hazards of thaw are accounted for in federal and international climate adaptation and mitigation plans. But even with the most ambitious action to control climate change, permafrost is already thawing. It's been happening for decades. And so we need to address these impacts immediately. So right now, communities across the Arctic are being forced to make really extremely difficult and unjust decisions about where and how to live in order to protect themselves from climate-induced hazards caused by permafrost thaw. And in cases, as you can see here, in many cases, the ground is literally sinking beneath the structure of people's homes. So we're working closely with our team members and partners who live on permafrost to apply some of these monitoring and modeling tools to assess the current and future impacts of permafrost thaw. And we're working to co-create equitable adaptation plans that respects the health, well-being, and human rights of Arctic residents. And we're doing this in part by partnering with several Alaska Native communities that are imminently threatened by permafrost thaw and other climate hazards. And we're working to support the creation of a relocation governance framework that respects the human rights of climate threatened communities and also ensures the right of self-determination and fosters long-term community and climate resilience. I'm going to wrap up there because I want to make sure to let my partners who are experts in these areas talk more about our approach for addressing these issues. So with that, I will say thank you, and I will stop sharing my screen.
Thank you, Sue. That was great. We're going to open now for audience questions. People can type questions into the Q&A and we'll try to get to all of them. I'm going to start off with some questions for the group. I wanted to ask, I was really struck by that last slide that showed the communities at risk in Alaska. And it's like, it's all over. For some reason, I thought it'd just be like Northern Alaska or, along the coast, but it's everywhere throughout the state. And I was wondering if Patricia could tell us a little bit about how the loss of permafrost is affecting communities in Alaska and the Arctic.
Sure. Well, good morning or good afternoon, everyone. I'm very happy to join you all today. And thank you to my fellow panelists for all of us being here today. I first of all need to start, as I do everything that I do in my daily life, by first of all giving thanks to the Creator for this beautiful day that has been given to us, by stopping and honoring all of our elders who are still with us and remembering all of our ancestors who have come before us. As Barbara has said, my name is Patricia Cochran. I'm director of the Alaska Native Science Commission, but I'm first and foremost an elder in my Inuit community. To me, that is of great significance and great value to the kinds of things that I hope to share with you today and to share with all of my community. Thank you, Sue, for remembering to do land acknowledgement from the Indigenous lands that you are upon, and by reminding all of us that we are, each of us sit upon Indigenous lands and peoples all across the world. So let me talk a little bit about the way that the Native worldview works. And this is kind of a huge topic of discussion, but in our way of thinking, one of the things we always say is that everything is connected. People wonder what that means when we say that everything is connected. But to us, in our Native way of thinking, it means that we see the synergies of the humans and the environment, of the land, of the air, of the water, of the humans, of the animals, that they're really all connected. And we don't silo things into just one particular way of thinking, but really trying to think of things as an entire ecosystem approach. So Sue was very helpful in showing a lot of the pictures, the things that are happening and that we're experiencing firsthand here in Alaska and the Arctic, and that we have been for decades. Let me make sure that people understand this, because some folks think that this is, just something that's happened within the last few years. But truthfully, it's been something that our people in the Arctic and Alaska have been talking about for decades. We certainly have seen the loss of permafrost and what that means to all of our communities. The loss of sea ice. Where I come from in Nome, my hometown, the loss of that sea ice in front of our community meant that our community in Nome gets overrun now with storms that are now able to creep into our city, into our communities. That ice is no longer there to protect us from the Bering Sea. We're seeing the increase in temperatures all across the Arctic and indeed across the world. But for us, it's meant a lot of things. Not only changes in species in plants and animals, but the fires that we have seen and are seeing today here in Alaska. The tundra fires that especially are prevalent in my area of the state and in Southwest Alaska, where there's a huge tundra fire that is now burning. The tundra fires that burn underground and can go on for months or even years, periods of time. These fires were created by lightning strikes that we're seeing sometimes thousands and thousands of them during seasons. The release of carbon into the atmosphere that Sue talked about. The melting of our ice cellars, which for us is a big deal because in the north in particular, that's where we've stored a lot of our food. So for us, that means the food security of our communities is also at risk. The sloughing of the land means damage to our infrastructure, to all of our homes, our airfields, the things that make our communities accessible, since many of our communities truly are only accessible by air. So not having that airfield available really makes a huge difference to our ability to survive well. The damage to the roads that our communities rely upon, and not the least of which is relocation that our communities are facing now. Many of our communities having to look to move from where the centuries of time that they've been living. And last, but certainly not least, is the health and sanitation issues that arise from our communities because of the loss of permafrost, where we see some of the utilidors, our sewer and water systems that are being damaged because of permafrost melt. That is bringing unhealthy environments to our communities. So these are just a few of the many things that we're seeing in our communities and that we have to live with every single day. And with that, I'll turn it back over to you, Barbara.
Wow, thank you, Patricia. That's amazing. I wanted to follow up with you, Robin, because your organization is going to be doing some adaptation work. And after hearing that, it's hard to, I can't even imagine, like, where do you start and how are you thinking about adaptation and how do you incorporate, human rights and environmental justice into that?
Thank you, Barbara, and thank you so much, Patricia, for beginning this session of questions. I live and work on the land of the Dena'ina, who have been stewards of these lands from time immemorial, and I'm honored to be part of this panel and to do this work. And to answer your question, Barbara, it's that right to self-determination that Dr. Sue Natali mentioned that guides our work. And what that means is that the tribes with whom we will be working and providing funding to will guide us in how they want to respond to the climate-induced hazards that are happening. And this is most critical on the issue of the awful issue of a community-wide relocation, where an entire community needs to make the decision about whether or not they can stay on the ancestral lands where they have been since time immemorial. And the way that we have done our work, so we've been doing this work with Alaska Native tribes now for the last 6 years, and is on community-based environmental monitoring. And the reason why that's so important is because the US government, not alone, but the US government has forcibly relocated Indigenous peoples. And most recently that happened during World War II when the Unungan people were relocated from the Aleutian Islands to Southeast Alaska and 10% of the population died. And so we cannot have any government making a decision about whether or not a tribe needs to relocate, except that tribal government or city government within that community making these decisions. And the information that is critical is what is happening to the environment. So of course, Indigenous knowledge holders know what's happening in their environment, but the challenge is to understand these predicted rates of change in regard to what are called slow onset environmental changes, like permafrost thaw, like erosion. And so the work that we have done in the past and that we will continue is to install with Dr. Natali permafrost thaw monitoring in communities so that they are gathering the data that they need in order to make these decisions, and then upscaling it to affect policy. Because one of the other giant challenges that we have, not only in the United States, but around the world, is that there's no, as Dr. Natali talked about, there's no relocation governance framework anywhere in the world, and there is none in the United States. And part of that is because of that historical legacy that I just talked about. But the other part is that most governments in the world have zero desire to manage the internal movement of people. And so we are asking the government to step into a place that they have a bad history for and don't really want to engage in this process of figuring out whether or not people can stay in their communities because of these environmental changes that are happening. So we are doing policy level work and understanding the laws that currently exist. For instance, in the Stafford Act, which guides the Federal Emergency Management Agency. And it's important to know that these laws were created before the climate crisis existed. So in my words, as a human rights lawyer, they're anachronistic the laws are anachronistic to the way the environment is changing, and the laws desperately need to be changed. So we do this work at the community level and then scale it up because all of it is critically important in order to protect the human rights and the human right to self-determination that needs to guide this work. Thank you.
Can I ask either Robin or Patricia, one thing that you said struck me was about calling it slow onset. And I was wondering if you could talk a little more about that. As it just looked like some of the stuff was happening pretty quickly, right? There's some of these like landslides. So I guess my question is, it seems like you have to figure out sort of what's gonna happen and how fast, and that will determine, you know, what sort of decision communities will make. Is that, and there's not, I guess what I'm trying to ask is like, where is the current understanding? Is there any sort of current understanding of how quickly things will go, or is that a big sort of unknown at this point?
Well, thanks for that question, and it's a great question. So that is an example of how our laws are anachronistic to the ways the climate crisis is impacting communities. So as I mentioned, the Stafford Act, that is the legislation that defines what a disaster is and determines when FEMA will provide funding and technical assistance to a community. You have to have a disaster declared. And the way disasters are declared in that legislation, it does not include things like erosion or permafrost thaw. It's hurricanes and landslides and things that are usually considered single events that overwhelm the capacity of a local or state government. And in the native village of Newtok, which is one of the Alaska Native tribes that has been trying to relocate for decades, they actually requested a presidential disaster declaration when President Obama was in office, because they are in an environmental crisis caused by climate change because of erosion and thawing permafrost. And President Obama denied this presidential disaster declaration, finding that it was outside the scope of the Stafford Act. And so that's why erosion is not necessarily a single event, and we need to change these laws in order for communities to access these type of resources, even when erosion or thawing permafrost are the things that are causing communities to make these decisions.
That is so interesting. Patricia, did you want to add anything to that?
No, I just would say that, you know, it's certainly from the community perspective, it's been both slow and fast, I would say. You know, we've seen so many things that have happened to us for a long period of time. It takes forever for anything to happen within our communities, for any decisions to be made and for the help to arrive. But for us, seeing these things happening on a daily basis, I guess it's a little bit of both.
Interesting. I want to get to some of the science questions in a second, but before we go there, Fran, I wanted to follow up with you on some of these policy questions. Like, what do we need a change to disaster declaration laws? How that's done, or would that help, or is it, I don't know, better to sort of circumvent the federal government at this point, or what sort of policy changes would help the situation?
Thanks, Barbara. And I am calling in from Anchorage, the ancestral lands of the Dena'ina people. And I appreciate both what Patricia and Robin have just described for you as not only the serious problem that is being faced in Alaska, but frankly also in Russia and in Canada and in many other places. And I think it's really important to remind people, and actually, Barbara, your point about, gee, you were surprised by the Alaska map and how there were dots all over. Well, I just want to remind people that 24% of the Northern Hemisphere is underlain with permafrost. So we've been talking about, you know, the US and Alaska and communities here, but I just want to remind us that it's not just a US problem. So yes, we need to amend the Stafford Act or create a parallel piece of legislation, which may be more appropriate to the kind of risks associated with the impacts to communities associated with climate change, both in Alaska and frankly, from Palo Alto to Boston to Miami Beach as well, because even though the nature of the impact of climate change is different in different places, and yes, we're talking about permafrost here, there are many other communities that face similar tough decisions about what is appropriate in terms of either reinforcing existing infrastructure or moving communities or just changing the way in which we permit land or insure buildings. I mean, there's a whole host of issues. So it may be both a Stafford Act and an entirely different act. And it needs to be first and foremost, a realization by people, regardless of where they live, of how widespread this problem and this challenge really is. So your question about policy is a broad one. Yes, it is very specifically as it relates to the imminent issues right here in Alaska, but it is a much broader question for our societies to deal with. You know, permafrost thaw as it is rolling out creates a number of policy challenges. Part of it is this adaptation piece and the resilience piece and equipping both people on the ground with the information they need to make these kinds of really difficult decisions. Also equipping the agencies and the partners that can be part of the process. But at this global level that Sue was talking about in terms of actually making the policymakers sufficiently confident in the numbers about the contribution of permafrost thaw so that the decisions made about what kind of climate action is really necessary to slow the rapid rate of change that our planet is experiencing, inserting those in decisions, whether it's, you know, at COP and big climate change conferences or in governmental policy all across the world. That is the policy piece where Harvard is trying very hard to provide some support and assistance. John Holdren, who leads our team at the Harvard Arctic Initiative as a partner with Woodwell, is one of the people who is incredibly well equipped and well connected to help with these international fora where decision makers really need to have confidence in the information and understand how permafrost thaw contribution is really an important piece in the targets that we are going to have for emission reductions. And it is sort of a whole host of policy pieces that are absolutely essential because it's not what's happening in the Arctic that is primarily contributing to permafrost thaw. It's what's happening globally. But yet this impact of global warming and decisions that are being made across the planet in policy and in investment and in individual choice and in industrial and energy policy is really what's driving this rapid rate of thaw, which is then contributing and accelerating the kind of climate impacts and disasters ahead for not just people in the Arctic, but for people around the world.
Thanks. Starting to get my heart rate up a little bit thinking about this permafrost keeping me up at night. You know, it's interesting too, because when you were talking about this sort of relocating communities, I mean, we're seeing the same thing, you know, around in certain areas of Boston and around Long Island, just not to, you know, the extent you guys are like, you know, ahead of us on this. So it's, you know, it'll be interesting to see how it plays out up there. And you know, maybe we'll be able to learn something from you that could help us figure out what to do in Boston. The one thing that came up in what Fran was just saying is about how we're talking about Alaska because, you know, we're in the United States, but the permafrost goes, you know, all around the Arctic, you know, and most of it's in Russia, I believe. So I wanted to talk to the scientists a little bit about, first of all, what do we know right now about how much carbon, methane, and carbon dioxide is being emitted, and why don't we know more, and why isn't it included in climate models? And how will this project fill these gaps? And will you be able to sort of, do you need that information from Russia and other countries as well? So I guess the question is, what do we know now, and what do we need to know, and how will we learn it? Brendan, and so you can fight over who gets to answer all these questions.
I can start, and then Sue can pick up. And yeah, there's a lot in there, so thank you. A lot to unpack. Maybe I'll start with the modeling piece. You asked why permafrost carbon is not included in climate models and what can be done about it. And just to stress how important this is, I mean, this is a major Earth system feedback, a major contributor to climate change that essentially is not being accounted for, both in terms of the climate models themselves, so the temperature projections that we're getting out of those, but also what we call our global carbon budget, and that is how much, what level of emissions we think we have left to emit as a society. And if it's not accounting for permafrost, then it's overestimating that. So in terms of the climate models, it's a big gap, and it's something that we are through this project have an exciting opportunity to address, a much needed opportunity that's been there for many years. Fundamentally, modeling global or circumpolar soil carbon is it's a hard task to do. What you really need to be able to represent permafrost carbon is to have carbon pools in your model that go through the soil vertically, because then you can get these temperature profiles. And the hard reality is that many of the models don't have that. But once you do that, that kind of just gets you in the door. Your model can represent permafrost carbon. The problem is that, well, there's a couple of problems. One is that only 2 of 11 models that were used in the last IPCC report, Intergovernmental Panel on Climate Change, included permafrost carbon. The second problem is that they don't incorporate all the proper loss pathways. And by that, I mean the emissions from permafrost thawing, the carbon emissions, the greenhouse gas emissions to the atmosphere. Because what they'll generally represent is warming the soil, which then gradually warms the permafrost, and some of it can thaw and decompose. The problem is we're seeing that, but we're also seeing a different picture play out across the Arctic. So Patricia mentioned fires, and Sue showed a picture of these abrupt thaw events. These are dynamic disturbances. They're increasing in frequency and often in severity or intensity with climate warming, and the models essentially don't represent that. So what we're doing, we're doing a few different things. One, we're developing a model that for the first time can account for all of these loss pathways of permafrost. So we're doing model development on these wildfires, on these abrupt thaw events. We're also modeling in a slightly different way. So we know that we need to collect more data in permafrost systems, but at the same time, the models that are out there use only a very small fraction of the available data. So we're building what's called a data assimilation model to incorporate a lot more of that data, a large fraction of that data across the Arctic to better constrain our models. So we're building a model that we think can kind of be used as a beacon in that way, but we also understand that there is an international global modeling community, and we need all of us to sort of work together to come along so that, for example, the IPCC assessments that use an ensemble of models, that in the next report, we can ensure that not just 2 of the 11 models are including permafrost carbon. So also working with that community. And then finally, Sue mentioned this briefly, but I think there's a little bit of a disconnect in terms of the type of information that these models are typically providing and the type of information that policymakers need. And by that, I mean, the models are typically run in these sort of long-term scenarios called representative concentration pathways or shared socioeconomic pathways. But what the policymaking community really is talking about and needs is information about what happens at 1.5 degrees Celsius, what happens at 2 degrees Celsius if we're able to sort of hit that target and then potentially go no further. And those scenarios don't always sort of tell you that information that you need. So we're also running a very sort of policy relevant model that's fast, is based on our more detailed model, and can run all these scenarios of temperature thresholds being met globally. What if you overshoot those? What if you just avoid them? Those types of scenarios, so we can directly give the policymakers the type of information that they need to incorporate this into global policy targets and emissions reductions. And then just to address your second question of how much could this be? I mean, I guess I would have 2 main reactions. One is it could easily be a big deal. And 2 is we don't know exactly how big a deal it is. And that's why the science is so important. It depends on these scenarios I talked about in terms of how we reach different temperature thresholds. early indications suggest that permafrost carbon could potentially emit up to 30 or 40% of what we think we have left to emit to stay within a 1.5 degrees Celsius budget. That's a big deal, right? Something like 2 degrees Celsius, there's more allowable emissions, so the percentage is lower. But if we include these disturbances I've been talking about, some preliminary results we have show that it could be 50% or more for 1.5 degrees, or it could be around a quarter for 2 degrees. And those, those in some respects, we don't know all the feedbacks that could be happening, and the levels could in fact be larger, which gets me to my last point, which is that we certainly have science that we need to do. We know we have to collect more data. We know we need to improve our models. That said, we know this could be a big enough deal. We have enough information within a risk framework to act, right? And so that's why we're pushing on the policy since day one, while at the same time setting up instrumentation and improving our models, because we want to be more certain, we want to be more confident in the numbers we're giving. At the same time, we know enough that we should be acting now, and we should be reducing our emissions this decade, which is very, very important. Okay, Sue, I don't know if you have anything to add to that, or
Can I just interrupt for a sec? Is there any chance that the emissions might be lower than your?
Sure, absolutely. So right now there's a very large range of where it could be. I certainly hope, believe me, I really, really hope they're lower. I'm not sure that they will be. And so if you think about it from a risk framework, like if you're buying insurance on your house, yeah, there's a chance nothing can happen, but there's also a chance that, fire or flood, whatever could happen. And so I think you really need to think about it until we have improved numbers from this risk framework. Hopefully it's lower. It could also be much higher.
Okay. So could you go? Oh, go ahead.
I guess I'll add, in terms of the risk framework, if nothing happens to your house and you spend money on insurance, you maybe lose some money. But in the case of climate mitigation, there's actually no losing. If you reduce fossil fuel emissions, there are so many other benefits, even if the permafrost feedback isn't as high as we think it is, protecting forests, protecting lands, respecting people. Like there are many, many other reasons for doing this. And so I'd say it's a win. There's no loss to, taking, seriously considering this risk and considering the high end of this risk and acting on it.
I'm going to ask some audience questions now. This is an interesting one. So what is the long-term effect of permafrost thawing on other regions of the world, right? So we can see very visibly what's happening in the Arctic and the physical effects of that. But is the permafrost thawing going to affect other regions as well climatically? And if not, why? I guess, how do you make people care about this? How do you get people to care about this?
Okay, I'll start. Yes, it will, because when permafrost thaws, the carbon that's in the permafrost can be released into the atmosphere as carbon dioxide and methane, which are global greenhouse gases. This is why there's so much climate warming in the Arctic, even though these fossil fuels are emitted elsewhere. So they're globally mixed. So it means when you release them from one part of the planet, they will make their way to another part of the planet. And when they're released to the atmosphere, they're in turn amplifying and accelerating climate change. And so that's the question of like when and how fast, where there is uncertainty, but definitely will amplify the effects that we're already seeing elsewhere on the planet. And then how do you get people to care? I mean, I would interested to hear from others on this panel. I mean, I guess for me, I think it kind of like, yes, there's the like, you should care because it impacts you, but I also think, or like to think, that people care about like other people and this planet, and like connecting with people as whatever, a family or a human, or I would like to think that it doesn't have to just be directly impacting individuals. But that it does. And so I guess there are other reasons, which are economic reasons, that people will be impacts on people's backyard. But I do think even if it was something that was not happening in people's individuals' backyard, that they could connect with, like, as a member of humanity, with what's happening elsewhere. But others maybe have a better answer.
I do like to think that that's possible. Yes.
Barbara, let me just say, I of course, Sue said the most important pieces of this. both in terms of global impact on warming, but also in terms of our caring about each other, as well as the indigenous communities. But there's one more piece of that. And as was pointed out earlier, it's all infrastructure in the north that's seriously at risk, including pipelines, including major defense facilities. So if you think about the amount of oil and gas in Russia, in the north, on permafrost, and the pipelines, same thing here in Alaska. The Trans-Alaska Pipeline has a whole host of effort. A lot of effort has been made to try to make sure that there isn't an oil spill associated with permafrost thawing of the pipeline. But if you think about sort of the environmental impacts associated with it as well, that's another kind of on the ground impact that sometimes people care about. And I would say that to the extent that other communities who are also facing serious problems associated with general climate warming. I mean, it's also the warming of the oceans, right? So it's not only why do people care because maybe they live in a place where they're already experiencing flooding, periodic, what they call sunny day flooding in places like Miami Beach, but also huge dislocations associated with the balance of productivity of our oceans that supply not only 50% of all of our oxygen in our atmosphere, but also the kind of ultimate problems associated with fisheries and with coral reefs and with general health of oceans. So, I mean, it's so, I realize it's complicated, but you have to kind of help people understand how these dots are connected and why permafrost thaw has this big potential, negative, hopefully less, but potential to impact them in many, many different ways.
Sort of goes back to what Patricia said at the very beginning. Is there anything else you want to add to that, Patricia, before we go to another question?
Well, I'll just say that in the many years that I've been working on climate issues over the last 50 or so years, I've had the opportunity to travel all over the world and to speak with fellow human beings all across not only the United States, but truthfully across the rest of the globe. We've had opportunities for indigenous peoples from all over to talk about these issues, from Africa to Asia to the Arctic. So it really has, it's brought us all together as communities. And the conversations that I have when I speak with farmers in Iowa and how what's happening in the Arctic really does impact what's going on in their communities. What we end up with is people understanding that there are reasons why the world needs to be concerned about what we're seeing in the Arctic, because as we say, we're the harbinger of what's to come. And we see this as what's happening in the Arctic as our opportunity to provide information to the rest of the world, how to survive the planet that we're all living in now.
Thanks. That's a good, heartening message. Thank you. We need a little of that, humanity. Okay, audience question. I think this is for the scientists. Do you feel that countries have underestimated methane emissions and over-prioritized carbon instead of equally addressing methane and carbon emissions via monitoring and policy? Anyone? Methane, carbon dioxide? What do you think?
Maybe I'll chime in, and yeah, if the other scientist Sue wants to add to it. I don't know about over or under prioritizing. I mean, I think in some sense, we're under prioritizing the whole thing, right? The urgency with which we need to reduce all of our greenhouse gas emissions, climate forcings. We need to do that now. We need to do this decade. This is a critical decade. In terms of CO2 versus methane, there are some important differences, right? So the carbon that's in permafrost now is sort of locked up in mostly organic matter, and when it gets decomposed and emitted to the atmosphere, it can go out either as CO2 or methane. It sort of depends on how wet or dry the environment is at the time, which of those loss pathways play out. CO2 is incredibly important. It's the most important greenhouse gas globally, leading to our warming. That said, methane is much more potent than CO2. It just comes out in smaller quantities. it also is shorter lived in the atmosphere. And so from a policy perspective, there is something to be said for going after some of these short-lived forcings while we sort of reduce our emissions otherwise and keep Earth systems like permafrost stable. So right now, there has been an uptick in methane globally. It's a little unclear where that's coming from. We are sort of concerned about this in terms of permafrost thaw. So from our scientific perspective, it's very much something that we are focused on. So the monitoring that we're doing in terms of supplementing these monitoring stations that are out there now and building new ones very much is focused on both CO2 and methane. And our modeling as well. So our model development includes a strong focus on making sure we account for not just CO2, but methane because of how important they both are. Sue, I don't know if you had anything to add to that.
No, I mean, that was great. I mean, I get the sense that the countries are focusing a lot on industry emissions, which is critical, but I do think there isn't enough attention paid to natural systems, and both in terms of releases of greenhouse gases like carbon dioxide and methane, but also in terms of their ability to remove greenhouse gases from the atmosphere. And so that's where I think there needs to be more attention, is sort of the protection and the ability of these systems to take up carbon, to store carbon in forests and in soils, among their many other benefits.
There are a bunch of audience questions about Russia and permafrost in Russia, and whether there's any coordination or cooperation with Russian scientists studying permafrost, and has the situation with Ukraine affected research at all?
I'll answer this just briefly. We and I don't know if Fran may want to answer from her perspective, but we, or others can answer as well. But in terms of the science that we're doing, we have Russian collaborators that we've been working very closely with. We continue to work them. They are on our steering committee. That said, we are not like on the ground in Russia. We're not sending instrumentation to Russia. That has definitely been halted. I think it's important to keep in mind that climate change is a global problem. And so we need to, I'm not sure like politically how this will happen, but I feel like on the individual level of scientists working with each other, most of the scientists that, or I'd say actually all the scientists that I know, are hoping that these collaborations will continue, because we feel like this work is really important, and the Arctic spans many nations. And so we need to figure out, we can't just work as single nations and think that we're going to make a lot of progress here.
Yeah, I would note that obviously the last few months have seen a lot of changes in how Arctic nations are working with each other. Many people on this call probably have seen the Arctic Council pronouncements about first putting everything on hold and then trying to resume certain things. The Sustainable Development Working Group of the Arctic Council had been doing work on what we have more generally called resilience, the adaptation piece of making certain that communities across the Arctic have the opportunity to talk to each other, learn from each other, and find successful models for building resilience. That is one of the areas in which we at Harvard at the Arctic Initiative with Jennifer Spence and Joel Clement and others have, over the last couple of years, held a number of workshops, and previously had a lot of participation, I would say, from all of the Arctic nations, the indigenous people of the Arctic, and really a robust sense of, it's not just the permafrost thaw, but as Patricia was saying earlier, it's all of the changes that are happening so rapidly in the Arctic that really challenge communities and provinces and states and countries to come up with resilient strategies. So I would say that work, in a slightly different way, continues as best it can. And unfortunately, because of the chilled relationships with Russia, and because some of the pronouncements by governments, including the US State Department, that has been, I wouldn't say stopped, but it definitely, sort of like permafrost scientist to scientist, some of that still continues, but not at an official governmental level. So we are hopeful that again, some of this resilience work, this adaptation work, can continue in a way that once we can resume a more trusting and normal relationship with the people in Russia who are very much interested in how do you build resilience into infrastructure? How do you change engineering and building practices? How can you work with communities as well as businesses to improve the local resilience of facilities in permafrost thawing areas? We are hopeful that that will resume.
Great. So another audience question about gaps in the U.S. policy infrastructure. So they ask this example of FEMA not covering the hazard from permafrost thaw or erosion, things like that. Are there other gaps in the U.S. policy infrastructure that prohibits folks from doing what needs to be done for adaptation and mitigation? Are there any sort of specific things? Go ahead, Robin.
Yeah, thanks, Barbara, for that question. So the biggest problem is we have no national governance framework. And what I mean by that is there is no one federal government agency that has the mandate or funding to address this issue. And the U.S. Government Accountability Office just published their 4th report on this issue. So the first report was done almost 20 years ago. I just need to repeat that 20 years ago, the U.S. Government Accountability Office did a report identifying in Alaska the communities that were threatened by flooding and erosion and identifying that there was not the appropriate governance structure to address what was happening in the Arctic 20 years ago. And that office just did their 4th report, basically, and these are my words, pleading with the US government to take action. And I agree with Fran, there needs to be separate legislation, and this is not part of the Stafford Act. And based on the work that we've done with tribes, we have proposed a national governance framework because, as Fran highlighted, the way the climate crisis is impacting communities, and I'm specifically focused on coastal communities because I think what people need to understand in regard to coastlines is land is going to permanently disappear, permanently submerged under sea level. And there are not going to be the funding or the technological ability to protect the coastlines of the United States, the entire coastlines. And you just look at Florida and Miami in particular, where sea level rises beneath the city. So you have sea level coming in because the city is built on limestone. So a seawall protecting that city from sea level rise is not going to address what's happening underneath the city. And so in our proposal of a national governance framework, one of the most critical things is for local communities, because this is really ecosystem dependent, identifying what the environmental and social thresholds are before there is an extreme weather event that displaces people like a hurricane, and people want to go back to that place and people are in crisis, so it's hard to protect their human rights and that right to self-determination. You identify what the thresholds are in local ecosystems so that in advance, you know when those thresholds are met, you need to then figure out a different process from protecting people in the places where they live. And then going back to, the conversation about community-based environmental monitoring, this is why it's so important, because the models that communities are receiving are at too high of a scale to be relevant at a very local level. And so one of the things that we are going to be doing with the Permafrost Pathways project is integrating that community-based permafrost thaw monitoring with the modeling that Brendan is talking about. So ground truthing it so that we're able to get much clearer predictions in regard to rates of change, in regard to not only permafrost thaw, but we will continue to do the erosion monitoring also, because those are the two indicators in the Arctic of when a community may no longer be able to stay where they are. And just in final, one of the things based on the community-based environmental monitoring that we have done, we identified a hazard in Alaska that is now part of our Alaska State Hazard Mitigation Plan. It is a Yupik word and it means Usteq. It is Usteq, U-S-T-E-Q, and it means catastrophic land collapse. And it is being caused by the combination of flooding, thawing permafrost, and erosion. So that need for a national governance framework to then figure out, to provide a standardized process through which communities can make these decisions and then receive the funding that they need to facilitate, whether it's protecting in place or relocation, is critically important.
Thank you. We are almost out of time. Before I hand it back over to Dr. Natali to wrap everything up, I wanted to offer each panelist a chance for sort of one final thought that they'd like to leave the audience with today. If you want people to walk away with one thing to be thinking about permafrost, what would it be? Patricia, why don't we start with you?
I guess the one thing that I would add to this is that to me, the most relevant thing about all of the issues regarding climate is to remember to put the human face to all of the issues that we are talking about today. That sometimes we get too wrapped up in the science and we forget about humanity. And for me, the most important thing is remembering that all of these conditions really affect human beings.
Thanks. Maybe we should have ended with you, but thank you. Okay, Fran.
Policymakers at all levels need to understand this in a way that they don't currently. And part of how they will get to understand it are projects like this one, but also people like you who are part of this audience who are willing to talk about it. A lot of people have no idea what permafrost is or why it touches their lives. And I encourage you to take what you have learned here today and share it with others.
Thanks. Brendan?
Yeah, I guess my one thing, and just thank you to everyone, the other panelists, to you, Barbara, to the audience. It's hard to boil down to one thing, right? We've discussed so many important topics. I guess if it's one thing, building what Fran said, I would hope that permafrost is a little bit more of a household name. And going back to our discussion a little bit earlier, that if emissions from permafrost are on the low end, the worst case is that we limit climate warming and limit damages all over the world. So we need to think in this risk-based framework, and we're a very critical window. The windows are barely open to stay within 1.5 to 2 degrees Celsius. So what we do now is really, really important.
Thanks. And Robin?
Well, following up on what Brendan said, it is urgent. I mean, I hope people listening to this webinar understand the urgency for action and that it needs to happen now. And whatever your role is in whether it's science, policy, or working with communities, and echoing what Patricia said, this is about people. This is about us and how we are going to survive in a climate altered world. And we need to be dealing with mitigation and adaptation right now.
Thank you all. Those really powerful thoughts from all of you. Thank you. Okay, could just hand it over to Sue to wrap things up. Thanks, everybody.
All right. Well, thank you, everybody, for joining, and thanks, Barbara, and to the panelists. And I guess just I will add one thing, or maybe reiterate one thing, is that it's not, it is, the situation is urgent and the climate has been changing for decades, but I don't want people leaving feeling like there's nothing that you can do, because yes, people will continue to be impacted, and the impacts are really devastating, but we can reduce that impact, and reducing that depends on what we do right now. And so greenhouse gases are globally mixed, and so everybody, no matter where you are, can have an impact on what happens in the Arctic. With that, if you'd like to learn more about the project, if we haven't answered your questions, we will, let's see, if we didn't get to your questions, or if you have additional questions, you can email us at permafrost@woodwellclimate.org. You can visit our website at permafrost.woodwellclimate.org, or follow us on Twitter or Instagram at Woodwell Arctic. And that's all I have. Thank you so much.
Wonderful. Thank you to all our panelists and for everybody who joined us today. It was really interesting, and thank you all for all the work that you're doing.